Swayam Prabha. Digital India. Educated India.
Welcome to the lecture 18 of the course on time series modeling and forecasting. Now, I am going to start the analysis of time series in frequency domain. So far, we have considered the time series analysis in time domain. In time domain analysis, basically we are interested in how the present observation has generated on the basis of past observations, and time domain analysis is actually based on the autocorrelation function or autocovariance function. Actually, you are interested in which lagged observations or past observations are highly correlated with the present observation, and then you can say that those lagged observations having more impact on the current observation. So, we are interested in how the time series has been evolved through the time. In frequency domain analysis, our main focus is on how the time series is generated by using different terms having different frequencies. So, our main focus is not on time, but it is on the terms of different frequencies involved in generating the time series, and such kind of analysis is called the frequency domain analysis. In frequency domain analysis, our main focus is on spectral distribution or spectral density function. Just like in time domain analysis, our main focus was on autocorrelation function. Now, before coming to the main topic, I am going to introduce some of the things like Fourier and inverse Fourier transforms, etc., which I am going to use later on. The discrete Fourier transform of a function h t, where the function h t is defined for t equal to t belonging to this set. The Fourier transform is h omega equal to, we take summation from t equal to minus infinity to plus infinity h t e to the power minus I omega t. Omega lies between minus pi to pi. So, basically you have transformed the function h to function capital H omega using this transformation, and this transformation is called the Fourier transform. The inverse Fourier transform of capital H omega is h t is equal to 1 upon 2 pi integral from minus pi to pi capital H omega e to the power I omega t d omega. So, using this Fourier transformation, you get capital H omega from small h omega t, and using this inverse Fourier transform, you get small h t from capital H omega. Now, suppose h t is equal to h minus t. You remember in the case of autocovariance function, gamma k is equal to gamma minus k. So, the autocovariance function satisfies this kind of condition. In that case, you can write h omega equal to, we take the term for corresponding to t equal to 0 first, which is h corresponding to t 0, you get h 0 and e to the power 0 means 1. So, you have h 0 plus, then you take summation t equal to 1 to infinity h t, then corresponding to positive values of t, you get a term h t e to the power minus I omega t, and corresponding to negative values of t, you get a term like h t e to the power I omega t. So, you can write capital H omega in this form, or you can write the Fourier transform in this form, provided h small h t is equal to small h minus t. Now, you know that e to the power I omega t plus e to the power minus I omega t divided by 2 is equal to cos omega t. So, we write this term equal to 2 times cos omega t. So, you get h omega equal to h 0 plus 2 times summation t equal to 1 to infinity h t cos omega t, and the range of omega we have taken from minus pi to pi. Then you also observe that cos minus omega t is equal to cos omega t. So, you can write h t equal to, actually you have the integral from minus pi to pi h omega e to the power I omega t d omega, and then you can write it as 1 upon 2 pi integral from 0 to pi h omega e to the power I omega t plus e to the power minus I omega t d omega. In fact, you have you break this integral in 2 parts. You take integral from minus pi to 0 h omega e to the power I omega t d omega plus integral from 0 to pi h omega e to the power I omega t d omega. Then h omega is equal to h minus omega. Now, in this integral you simply take the transformation, say omega star equal to minus omega, then you get the integral from 0 to pi h omega star, that is h minus omega e to the power I omega star t d omega star, and then you write omega star equal to minus omega. So, finally, you obtain this integral. Now, again this term is equal to 2 times cos omega t. So, this is equal to 1 upon pi integral from 0 to pi h omega cos omega t d omega. Then some of the results of trigonometry we will also require, and these are the results. You can write sin A plus or sin A minus sin B in this form. For sin A plus sin B, it is 2 sin A plus B by 2 cos A plus A minus B by 2, and when you have minus sign here, then you get sin A minus B by 2 here and cos A plus B by 2 here. Similarly, you can write cos A plus cos B equal to 2 cos A plus B by 2 cos A minus B by 2. You have cos A minus B equal to this. Then for all k equal to plus minus 1 plus minus 2 and so on, sin k pi is equal to 0, cos k pi is equal to minus 1 to the power mod k minus 1, sin minus A is equal to minus sin A, cos minus A is equal to cos A. So, these results we may require while doing different derivations. And now we come to the main topic, spectral analysis or frequency domain analysis. Now, the first question is, what is spectral analysis, or what is the main focus of spectral analysis? So, the main objective or main focus of spectral analysis or frequency domain analysis is decomposition of a time series into underlying sine and cosine functions of different frequencies. So, basically you want to decompose the time series into different sine and cosine functions. So, basically you assume that your time series is consist of a mixture of sine and cosine functions of different frequencies, and then you are interested in decomposing those sine and cosine functions. Such kind of cycle dynamics is of main focus in many applications. For example, in infectious disease data, suppose you have infectious data of some disease, then you may observe some kind of periodicity, and there might be the reason of environmental factors for those periodicities. Means some of the infections get increased during rainy season, or some of the infections get more severe during winters. So, those cycles may be due to environmental factors, or those cycles may be due to inherent periodicity of immunity or partial immunity to infections. Means suppose at some point of time a large population gets infection, then after a certain period that large population, when that population gets recovered, So, infected population gets some kind of immunity or partial immunity to that disease, and that immunity may last for say 4 months or maybe for 6 months or for 1 year. So, for a certain period. Suppose that immunity lasts for 4 months, then after 4 months there is a big chance that that particular infectious disease may reoccur. So, after one pandemic period, there is a big chance that after 4 months you may face another pandemic period. These cycles may be due to the combination of both, means the combination of environmental factors as well as inherent periodicity of immunity. Now, in such kind of data, you may not be interested in time domain analysis, how the infection is behaving through time, but you may be more interested in the periodicity of the infection. Means once you face one pandemic period, after how many months or how many years it is going to recur. So, you may be interested in that period when there is more chance of getting another wave of pandemic. So, your main interest is in the cycle dynamics rather than the time related dynamics. Then you also have business cycles. So, same is the case with business cycles. You may be more interested in magnitude and periodicity of the cycles. You may find many other examples also. For example, in rainfall data, you may observe periodicity, not only seasonality. You may observe say after 5 years you may find some period where rainfall decreases for a certain year, does not rain much. So, you may find some kind of periodicity in rainfall data also. In fact, you must have observed that this kind of periodicity you observe in many crops. For example, mango crop. Say after some years you may find a certain period or a certain year which has much less mango crop than the other years. So, you may find some kind of periodicity in mango crop or some other crops. So, basically in the spectral analysis or frequency domain analysis, we are interested in decomposing a stationary time series into a combination of sinusoids with random and uncorrelated coefficients. Then you decompose the entire variation in the time series into different sinusoids, means different sine and cosine waves. Of course, we take the coefficients to be random variables and then we try to identify those frequencies that appear particularly strong or important. Means you want to identify the periodicities or the periods which have large impact, pronounced impact on the time series. Then spectral analysis can be viewed as a linear multiple regression problem. In this spectral analysis, the dependent variable is y t and the independent variables are the sine and cosine functions of all possible discrete frequencies. Now, you just compare it with the say autoregressive model. Autoregressive model is also a regression problem. You regress y t on the past values of y t, and then you try to identify those coefficients which are significant, means those lags which have significant impact on y t. Now, here your main focus is on the frequencies. You are running regression between y t and your independent variables are different sine and cosine functions. And once you run the regression, you want to identify those frequencies which have most significant impact on y t. So, the time domain approach considers regression on past values of the time series and shocks. So, in autoregressive model, we consider only past values of the time series. In moving average models, we have regression of current value of y t on the past values of shocks. In ARMA model, you have regression of y t on past values of y t's and past values of shocks. In frequency domain approach, we consider regression on sinusoids, regression of y t on sine and cosine waves. So, that is the difference between time domain and frequency domain approach. Then a spectral density function is required for studying the frequency properties of a time series. In time domain analysis, you require autocovariance function or autocorrelation function for studying the time domain properties of a time series. How the current observation is related with the past observations or past shocks. So, this information you get from the autocorrelation function or autocovariance function. In frequency domain analysis, your main focus is the spectral density function. Then the inferences regarding the spectral density are called the analysis in the frequency domain. You use spectral density for making inferences regarding the time series, and such kind of approach, such kind of analysis is called the frequency domain analysis. Now, suppose your time series contains a periodic component at a known frequency. So, you write your time series as a cosine wave y t equal to r cos omega t plus theta plus u t. Here u t is the random shock or purely random process. And then your time series contains one periodic component which has frequency of the periodic variation omega. And suppose we take the range of omega from 0 to 2 pi, then r is the amplitude of the variation and theta is the phase. So, your time series has a periodic component with amplitude r, frequency omega and phase theta. Now, suppose you assume that r, omega and theta are constant, then see what happens. So, if r and theta are constants, expectation of y t is equal to r cos omega t plus theta. So, this is the mean of the process. And this mean function depends on t. T is also involved here in the mean function. So, this shows that the process is non-stationary process. It is mean non-stationary because its mean depends upon t. So, now we assume that r is a random variable with 0 mean and it has finite variance. So, if we assume that r has 0 mean and finite variance, then what is expectation of y t? Then you have to take expectation of r also. Expectation of r is 0. So, expectation of y t is 0 and then the mean function becomes independent of t, it does not involve t and the process becomes stationary. Now, suppose we assume that theta is a random variable following uniform distribution over the interval 0 to 2 pi. Then again expectation of y t is equal to integral from 0 to 2 pi and you have 1 upon 2 pi here, r now r is fixed. So, you can take r outside the integral sign cos omega t plus theta d theta and then this is equal to r upon 2 pi sin omega t plus theta, the range of theta is from 0 to 2 pi. So, finally, you have term sin omega t plus 2 pi minus sin omega t here and sin omega t plus 2 pi is equal to sin omega t, therefore, you get 0 here. So, again expectation of y t is 0 and the process is stationary. Now, we consider Fourier representation of a series. So, suppose f x is a reasonably well behaved function defined over a finite interval, say x lies between 0 to L of the real line. Then you can approximate the function f x by a weighted sum of sine and cosine functions of the harmonically increasing frequencies. So, you can write f x as summation j equal to 0 to k a j cos 2 pi j x upon L plus b j sin 2 pi j x upon L. So, this representation is called the Fourier representation of the function f x. Now, you have this time series sequence y t, and you may regard this time series as a function mapping from set of integers, means set of values of t. This is the set of integers onto the real line. So, y t belongs to the real line. And then you can represent this time series as a Fourier series, or you can apply a Fourier series representation to this time series. Now, suppose the variation in a time series is governed by variation at different frequencies, means the time series has variation because of the terms of different frequencies present in the time series. Then we can write we can use this general model for the time series y t equal to summation j equal to 0 to k r j cos omega j t plus theta j. Now, this is actually the Fourier representation of the time series, just like this Fourier series. So, what it implies, your time series y t has components or cosine waves of different frequencies, different phase and different amplitudes in it. Or your time series is composed of a mixture of cosine waves of different frequencies and different amplitudes. Naturally, those cosine waves have more pronounced effect on y t, for which this amplitude is large, and if corresponding to some frequency, this r j is very small in magnitude, then you can say that that particular frequency does not have much effect on y t, or that particular frequency has insignificant effect on y t. Okay, so this r j is the amplitude at frequency omega j. Now, if omega j, r j and theta j are fixed constants, then if you take expectation of y t, what you get? If you take expectation of y t, and if you assume that r j, omega j and theta j are constant, then this is a function of t. So, expectation of y t changes with time and the process is non-stationary. But if we assume that R j's are uncorrelated random variables with 0 mean and finite variance, all theta j's are random variables following uniform distribution over the interval 0 to 2 pi, then the process is stationary, because in both of these cases, say suppose you take R j as a sequence of uncorrelated random variables with 0 mean and finite variance, then if you obtain expectation of y t, since expectation of R j is 0, so expectation of y t is also 0, you can also obtain the variance of y t, which is also a constant, and again if you assume that this theta j follows the uniform distribution, then also expectation of y t is 0. So, in both the cases, either you require this assumption, means you assume that the amplitudes are uncorrelated random variables with 0 mean and finite variance, or you take this assumption, theta j's are random variables following uniform distribution over the interval 0 to 2 pi to make the process stationary. Now, you can write cos omega j t plus theta j in this form also, and if you substitute this form in model 2, then y t becomes summation j equal to 0 to k a j cos omega j t plus b j sin omega j t, where a j is equal to r j cos theta j and b j is minus r j sin theta j. Again we write a j equal to d capital A omega j and b j equal to d capital B omega j. d A omega j and d B omega j are step functions with discontinuities at the points omega j. Then again you can write 3 as y t equal to summation over j d A omega j cos omega j t plus d B omega j sin omega j t. And if you take limit k tending to infinity, then the summation is replaced by integral to give this representation, y t equal to integral from 0 to pi cos omega t plus d A omega plus integral from 0 to pi sin omega t d B omega. Now, A omega and B omega are uncorrelated continuous random variables defined over the interval 0 to pi. This particular representation y t of y t is called the spectral representation of the process. Then we define omega cos omega t sin omega t and y t for all values of t in this range, means the entire set of positive and negative integers. Then the representation 5 implies that every frequency in the range 0 to pi may contribute to the variation of the process, means y t involves every frequency in the range 0 to pi, or every frequency in the range 0 to pi has contribution in the variation of y t. Now, we make these assumptions about A omega and B omega. Expectation of d A omega is equal to 0, expectation of d B omega is 0. For omega for all omega and lambda, expectation of d a omega d b omega is 0, expectation of d a omega d a lambda is equal to 0 for all omega not equal to lambda, similarly for b also, and variance of a d omega is equal to variance of d b omega equal to twice d f omega. Now, we define d z omega equal to 1 upon 2 d a omega minus I d b omega, and d z star omega equal to 1 upon 2 d a omega plus I d b omega. And so far we have taken the domain of a omega and b omega from 0 to pi, but now we extend it to from minus pi to pi. And then we just consider a minus omega equal to a omega and b minus omega equal to minus b omega. So, a omega is even function of omega and b omega is odd function of omega. Then you can easily verify that d z star minus omega is equal to minus d z omega. In d z star minus, you take just in place of omega, you just take minus omega, then you can easily get it equal to minus d z omega. Further, we observe that expectation of d z omega d z star omega is equal to d f omega. Actually, this d z omega d z star omega, this is equal to 1 upon 4 d square a omega plus d square b omega. Then when you take expectation of this quantity, you get expectation of this expectation equal to 1 upon 4 variance of a omega plus variance of b omega. And then variance of a omega is equal to 2 d f omega, variance of b omega is 2 f omega. So, this is equal to d f omega, and for omega not equal to lambda, this expectation is 0. Then you can write the representation 5 as y t equal to, you have this representation, and then we write cos omega t equal to e to the power I omega t plus e to the power minus I omega t upon 2, sin omega t equal to e to the power minus e to the power I omega t minus e to the power minus I omega t upon 2. You further simplify it as y t equal to integral from 0 to pi e to the power I omega t d a omega minus I d b omega upon 2 plus integral from 0 to pi e to the power minus I omega t d a omega plus I d b omega upon 2. Now, d a omega minus I d b omega upon 2 is equal to, we write it in terms of z omega and z star omega. So, this is equal to d z omega and d a omega plus I d b omega upon 2 is equal to d z star omega. And then when the integral is extended to the range minus pi to pi, then you have y t equal to integral from minus pi to pi e to the power I omega t d z omega. Now, this gives you the spectral representation of the time series y t. So, we have two different spectral representations of yt. Of course, both are equivalent. One is of this form, yt equal to 0 to pi cos omega t d a omega plus integral from 0 to pi sin omega t d b omega, and another representation is of this form. Both of these representations are equal, and from both the representations you get the basic idea or information that the frequency of the range 0 to pi or minus pi to pi, whatever you want to consider, are contributing in the variation of yt. Your problem is to find those frequencies which have significant effect on yt, because those are the frequencies which are going to dominate the variation in yt. Because of those frequencies, yt is varying, and the inferences drawn on those frequencies can guide you for the different kind of actions, different kind of requirements of your problem. Say, for example, initially we had taken infectious disease example. Now, suppose you observe that on the basis of your data, you observe that a period of 4 months is dominant in the variation of your time series. Then you can plan your actions accordingly. Now, you know that after 4 months this disease is again going to reoccur. So, accordingly you can prepare your hospitals, your medical facilities, your medical staff, etc. So, this is how identifying the dominant frequencies which drive your time series variability, or which have more pronounced effect on the moments of your time series, are important. So, in the next lecture I will consider the similar kind of representation for the auto covariance function of the process, and then how you can obtain the spectral density function for different time series processes like auto regressive, moving average, or even R-mark processes. So, now I am going to stop here. Thank you.
Hi, I'm Chitwan Lalji, a PhD student of Health Economics under the supervision of Dr. Debayan Pakrashi. from the Department of Humanities and Social Sciences, IIT Kanpur. In one of my essays, I am interested in understanding the relationship between consumption of fruits and vegetables and various health indicators. Health indicators, both subjective and objective health indicators like mental health, self-assessed health, various measures of blood pressure and various measures of cholesterol. Measures of blood pressure like systolic and diastolic BP. You have your incidence of high BP, MAP and incidence of high MAP. And as far as cholesterol is concerned, I have tried to concentrate more on total cholesterol, good cholesterol and incidence of high cholesterol. Now before I go on to what have been my major contributions and various policy implications, I would like to briefly tell you about the policy initiatives of WHO and various countries. The WHO, that is the World Health Organization, it started with a campaign of 5 a day. That is, you should have 5 portions of fruits and vegetables per day. That would be approximately, you could say, 400 grams of fruits and vegetables. Now, a portion, before we go further, I'll just tell you what exactly is a portion. One portion is equivalent to a medium-sized apple, or one small glass of fruit juice, which is approximately 150 milliliters, and maybe 3 teaspoons of vegetables. So, the WHO went with the 5 a day campaign, which was further taken up by various countries. Countries like UK, Netherlands, Germany, Norway, they adopted the 5 a day policy, while some went for expansionary dietary policies like France, Australia, Canada, Denmark. So, for example, Australia, it went for 2+5 policy, in which it said that you should consume 2 portions of fruits and 5 portions of vegetables per day. And USA went for a policy of fruits and vegetables more matters. That is, you must consume more and more fruits and vegetables. Now, irrespective of these expansionary dietary policies and dietary propagations, it has been found that only 28% of women and 25% of men, they actually meet the recommended dietary norms of 5 a day portion. So, the major contribution of my work is firstly to find an association between fruits and vegetables, whether there exists a relationship between fruits and vegetables and health indicators, and if they exist, whether due to heterogeneity in the data. So, I will be doing it according to age, by gender and by your weight. So, apart from that, I will go for policy recommendations, in which I am basically studying how much fruits and vegetables matter. Apart from that, which type matters more. So, for that, I have taken data from the Health Survey of England. Health Survey of England is an annual survey which takes data, which conducts information regularly on demographic and socioeconomic characteristics. You have your lifestyle behaviors like an individual smokes or doesn't smoke, alcohol consumption, you have your sedentary and physical activities, and you have various health indicators also which have been collected. Before I go on to what exactly is my research, I would like to concentrate more on fruits and vegetables, like what kind of questions were asked in the survey. Questions like, what kind of fresh fruit do you eat? Did you eat any dried fruit yesterday? Don't count dried fruits in cereals, cakes. Apart from that, for vegetables, they asked how many tablespoons of vegetables did you eat yesterday? So, approximately after this whole survey was conducted, data was converted into portions of fruits, and like for example, 3 tablespoons of vegetables is equivalent to 1 portion. So, data was converted and provided to the users, that is us, from the UK Data Health Survey. So, the major contributions of my paper is that I found a strong negative association between intake of fruits and self-assessed health, then various measures of blood pressure like mean arterial pressure, high blood pressure, systolic and diastolic BP, and your total cholesterol. Apart from that, I have found a strong positive association between consumption of vegetables and good cholesterol. So, it is recommended in a way that if you want to control your blood pressure, you must consume more and more fruits. And as far as vegetables are concerned, they impact your good cholesterol. Apart from that, I went in for a falsification test. A falsification test is basically conducted to know whether the model that you have adopted and the conclusions that you are drawing are not spurious. So, if a falsification test is done to know, in a way it is tested by seeing an indicator, a health indicator which is not being impacted by your consumption of fruits and vegetables, and then we see whether there is significant result or not. If there is no significant result, that means your model is good and your results are non-spurious. So what we did is, for falsification test, we took ear complaints and infectious diseases. Now ear complaints, like if you are deaf since birth or you have some kind of imbalance, body imbalance, that is not being impacted by your consumption of fruits and vegetables, and we did find insignificant results. Apart from that, infectious diseases like HIV, AIDS, etc., we found similar insignificant results, indicating that our results are not non-spurious. Apart from that, we went, since there was a lot of heterogeneity in the data, like by gender, by age and by weight, we did the regression analysis. We found results which stated that as far as fruits are concerned, it impacts a male's health more than a female's health. So it is basically said a man should consume more fruits to impact his health, whereas as far as vegetables are concerned, they impact a woman's health more. But this has been only seen as far as cholesterol is concerned, the various measures of cholesterol like total cholesterol, good cholesterol and your incidence of getting high cholesterol. Now after this, we went in for a policy implication, and in the policy implication we tried to find two policy implications: what matters and exactly how much portion matters. So as far as how much portion matters, we have found that on an average 5 or more portions of fruits impact your overall health, that is your self-assessed health, your MAP, your incidence of high MAP and incidence of high BP. But if you want to have a good mental health, so you can optimize your mental health by consuming 3 or 4 portions of fruits as well. And similarly, as far as self-assessed health and total cholesterol is concerned, an individual must consume 4 to 5 portions to optimally have the impact of consumption of fruits. Apart from that, vegetables have had a very little impact on your health. It only impacts your incidence of getting high MAP and high BP, and it's seen that only it impacts when you consume 5 or more portions of fruits. So an optimum consumption of 5 or more portions of fruits and vegetables are recommended, but fruits have a more impact on your overall health on various measures like self-assessed health, mental health, your various measures of blood pressure and various cholesterol levels. Another thing that we find is which type of fruit matters. It has been seen that all size fruits, they impact your self-assessed health, your systolic and diastolic blood pressure, your mean arterial pressure, your high BP and incidence of getting high MAP and high cholesterol. But we find that as far as frozen fruits or canned fruits are concerned, they help in regulating your incidence of getting high MAP or high BP, but it has a trade-off. That means there is something negative happening. It reduces the good cholesterol in your body. Apart from this, if you have an incidence of getting high cholesterol, it is recommended that you must consume fruit juices because it has a impact in reducing your probability of getting high cholesterol. And dried fruits, they impact your self-assessed health. As far as vegetables are concerned, very little impact has been seen. It has only been seen in case of portion of salads and its association with self-assessed health. Another thing that they have seen is vegetables in composite, they have an association with good cholesterol. So overall, my research basically says that there is an association between consumption of fruits and vegetables and various health indicators, and it is highly recommended that an individual, in order to be healthy, must consume 5 or more portions of fruits and 5 or more portions of vegetables per day, but fruits have a more impact on your overall health. Apart from that, all size fruits, they have a better impact on your overall health, your mental health, various measures of blood pressure and cholesterol. So, thank you.